Okay, let's find the complement of sine and cosine. First thing I want to do is I want to start off reviewing what supplementary angles are, complementary angles, and acute angles. So supplementary angles are two angles that add up to 180 degrees. Complementary angles are two angles that add up to 90 degrees. And we're not going to be using supplementary angles here. We're going to be using complementary angles. So that means two angles that add up to 90 degrees. And acute angles are any angles that are smaller than 90 degrees. So if we start off with a right triangle, and whenever we're using trig, we have to start off with a right triangle. So if we start off with a right triangle, we know that these two angles have to be acute angles. They have to be smaller than 90 degrees because any triangle, in any triangle, the interior angles add up to 180 degrees. So if we have a right triangle, 180 minus 90 leaves 90 degrees for these two angles. So if they have to add up to 90, they obviously both have to be smaller than 90, okay? And the complement of one of these angles would be the other angle. If a complement means two angles that add up to 90 degrees, the complement of one angle is the other angle that adds up to 90 degrees. All right, let's review a little bit of the sine and cosine functions we learned last week. We're not going to be talking about tangent. We also learned tangent last week, but when we find the complements, we're only going to be concerned with sine and cosine. And just real quickly, these funny looking symbols here, well, this kind of looks like a B. This doesn't really look like maybe like a fish, but it's supposed to be a Greek letter for A, and it's kind of how it's drawn here. And it's the Greek letter for A, and this is the Greek letter for B. And they just stand for an angle. I probably should have written them on the inside of the triangle, but you understand that it was just a little easier to write them on the outside because I'll be writing some other stuff on the inside. So since the alpha's here, this would be the angle we're just calling alpha, and this would be the angle we're just calling beta. Remember last week we also used the symbol theta, which is just the Greek letter for T. It's a circle with a line in it. Okay, and that would just mean this angle, or if it was down here, it would just mean this angle. So alpha and beta are just symbols showing that we're talking about this angle or we're talking about this angle. So if I want to find the sine of alpha, that means the sine of this angle. Remember, sine is a ratio made up of the side lengths of the triangle. And sine is opposite over hypotenuse. Remember, so, ka, toa. That's an easy way to remember. Sine is opposite over hypotenuse. So, S-O-H, ka, C-A-H. And we're not going to use toa, the tan, today. All right, so let's keep going here. Okay, to find the sine of alpha, that would be the opposite side from angle alpha and the hypotenuse. Well, the opposite side has a length of 4, and the hypotenuse is directly across from the right angle. That's 5. Well, let's look at cosine of B. So now we're finding cosine of the opposite angle. So this angle in here. Well, the adjacent side to angle B would be 4, and the hypotenuse would be 5. So what we see here is that, well, the ratios for sine of alpha, sine of this angle, is 4 over 5, and cosine of beta, cosine of this angle, is also 4 over 5. So sine of alpha equals cosine of beta, and that's important to remember. So if I want to find the complement of sine of angle alpha, or just sine of angle alpha, that would be cosine of beta, okay? So we don't know in this case how many degrees alpha is or how many degrees beta is. We just know that it's a truism that it'll always be true that the sine of alpha equals the cosine of beta. So now let's actually put this in progress here. Okay, find the complement of cosine of 29 degrees, and let's put little degree symbols there. Okay, cosine of 29 degrees. So we want to find the complement of this angle right here. So that's going to be this angle, and so we want to find the complement. Well, if we start with cosine, we know the complement is going to be sine, and the formula is 90 degrees minus theta, where theta is the angle you already have. So it would be sine of 90 degrees minus 29 degrees equals sine of 61 degrees, right? This would be 61 degrees. So the complement of cosine of 29 would be sine of 29. Okay, and over here, find the complement of sine of 42. Well, if we start with sine, we know it's going to be cosine, and it's going to be cosine of 90 degrees minus theta. And remember, again, theta is just a fancy way of saying, well, this angle. Kind of theta is just the angle we're talking about. So cosine of 90 degrees minus 42 degrees equals cosine of 48 degrees.